The most common way to form an epoxide is using a special reagent called mCPBA, which stands for metachloroperoxybenzoic acid. You don't really need to know the name or the structure, but just to show you what it is. So we have a benzene ring with a chlorine and meta. If this were just a benzoic acid, we would have double bond O, OH, that would be metachlorobenzoic acid. But this is a peroxybenzoic acid, and peroxy means that there are two oxygens. So instead of the OH, we have OH. And this peroxide is sort of extra reactive. And what that does is effectively adds a single oxygen across a double bond. So you can imagine if we have something with an alkene in it, and we use mCPBA as the reagent. All right, what we're effectively doing is adding an oxygen across that double bond. The double bond goes away. And if we form a single bond to the oxygen with each carbon that was part of the double bond, we get our epoxide. Now, in terms of the stereochemistry of this addition, the oxygen is going to add from either side of that double bond, but both bonds to the oxygen have to be in the same direction. All right, and I'll show you what I mean by that. So let's say we have this ring here, and we're going to add mCPBA to it. So this oxygen can add from either side of the ring. It can add from the top, the same side the phenyl was on, or from the bottom. Just like you have two sides of a paper, this planar double bond has two sides as well. So if the oxygen adds from the front, we're going to put it on wedges. It can also add from the back. And we'll put it on dashes. So if we want to consider stereochemistry, that's the way to think about it. The phenyl group here at this chiral center, don't mess with it. It doesn't change. It doesn't get affected during the reaction.